Hi everyone. This is an example of a percent composition by mass style problem. Let's work out the percent composition by mass for each element in the compound potassium sulfate. My first step is to determine the formula for potassium sulfate. Now potassium is a 1 plus ion and sulfate is a 2 minus. A 1 plus and a 2 minus gives me K2SO4. I need two potassiums to balance the charge of one sulfate polyatomic anion. Now I need to work out the molar mass. Normally in a regular question I would be doing it all just on my calculator screen. However, because I'm going to need each element's contribution to the molar mass, I'm going to be a little bit more methodical in my approach. The first step to that is to list the elements present. It shouldn't take more than 1 second. There's potassium, there's sulfur, and there's oxygen. There's K's, S's, and O's, no problem. Now, the next is how many? How many K's? 2. How many sulfurs? 1. And 4 oxygens. Again, should be really easy. Now I need to go to the periodic table, or just from my mind, remember the atomic masses for these atoms. Potassium is 39.10, sulfur is 32.07, and oxygen 16. I'm going to multiply here. 2 times 39.1 is 78.20. 1 there is 32.07, and 4 sixteenths is 64. Now I'm going to add those values up. The molar mass of potassium sulfate, K2SO4, is 174.27 grams per mole. In order to find the percent composition, I'm going to express each element's contribution to the molar mass as a percent. The overall molar mass is 174.27. The potassium's contribution to that was 78.2. I need to change that into a percent. I'm going to do that for the potassium, the sulfur, and the oxygen. I'm going to round off to 2 decimal places. I'm going to be conscious, though, when I'm actually given a problem to maybe some instructions included in the question itself. So, I have the percent for the potassium first. Well, it was 78.20 out of 174.27. And I'm going to need to multiply that by 100. What about the calculation for the sulfur? The sulfur contributed 32.07 to the total. Multiplied by 100. And the same sort of calculation for the oxygen. The oxygen's contribution was 64 to the total. It gets a little bit repetitive to write that same number over and over each time. Look at what happened though. By taking my time and being quite methodical actually in working out the molar mass, any number that I needed for the percent calculation was generated. It was this over the total, the sulfur's number over the total, and the oxygen 64 over the total. So it's a little bit time consuming to work all of this out, but it's quite doable. I just need to be careful with my calculations now. I have 78.2 out of 174.27 multiplied by 100. Again, I'm going to not write down the raw answer. I'm just going to look at the raw number on my calculator screen and round it off to 2 decimal places. This is 44.87%. 44.87%. What about the sulfur? 32.07 out of 174.27 times 100. This time 18.40. And finally, the oxygen, 64 out of 174.27 times 100, 36.72. 36.72%. When I'm finished, I can double check by adding those percentages up. Here I have 44.87 plus 18.4 plus 36.72. Here, because I was rounding, they all add up to actually 99.99, and that's okay. There's this really tight window of range that's going to be acceptable. Because we are rounding, they might not add perfectly up to 100, and this is an example that shows that. These 3 percentages add up to 99.99. That's okay. It's also all right if we had 100.01. Anything outside that, we might have made a rounding error. When we're asked to find the percent composition by mass, we might be asked for specific elements, or the question might be a little bit more wide open, where we have to find each element's composition. The first step is to find the formula, if we don't have it already given to us. And then, if we really methodically work out the molar mass, any number that we might need is going to show up. We take each element's contribution to the molar mass and divide by the molar mass, and then multiply by 100 and pay attention to round appropriately. I hope that helps.